Oh, hi.
Pick a card.
Any card?
Any card.
Explain containerization. I can do that. So funny you should ask. We started out with a problem, and that problem was the overall complexity of the services that we hosted in our Azure cloud. We had multiple database types, multiple languages and frameworks we were using within our web services, and multiple hosted types of UI applications. And as our web services and applications grew, so did the number of frameworks and languages that we used. And all of that made the process of setting up a local development environment incredibly complex, to the point where all of our engineers, both in the US and India, to do all of their engineering and all of their testing against our cloud services, which rapidly drove up costs as our Azure spending doesn't just come from the number of services that we use, it's the amount of data that we transfer back and forth. And these tests and engineering connections were running up costs very, very quickly, along with the sheer number of environments that we were managing. Because we were managing 4 different environments: production, staging, QA, and dev. And we looked at this and asked ourselves if there's any way that we can simplify this whole process. And that's where we decided to bring Docker into the mix. So the idea was to pull Docker into our engineering process and our continuous integration processes to simplify this whole stack, to make every service agnostic of the languages and frameworks that needed to be used, and to reduce the number of requests out to these services and the sheer number of environments they were managing. So by setting up an easy to build Docker environment for all of our engineers, we were able to cut out all of these connections to our remote services. And in the long run, also cut out some of the needless non-prod services that we were managing in Azure. And so this also led to a solution for a problem that we had in the future, which was we have customers who would like to manage our entire suite of web services in their local premise. So without any connections to the outside world. So we would need to take this entire cloud platform and host it in a local building without any connections to the outside world. And that is where Docker came in. So that led to the solution that we've been cooking up with containerization for the past 6 months. So we started from the very beginning, which was to containerize all of our services, databases, and web applications. This was the easy part. All we had to do was drop a Docker file into each one, and our databases themselves actually had open source images available in Docker Hub that we can just pull from right away. So that was taking care of us right out of the box. Then we moved on to our web services and applications. Again, just as easy as dropping a Docker file in, running a Docker build, and then pushing that to our remote container registry. From there, we still had a problem, which was this series of connections and integrations between all of our services still needed to be configured by the engineers who were setting up the environment on their local machine. So we took this one step further and pulled in Docker Compose. So we wrapped our entire suite of services in a single Docker Compose script, which allowed us to pre-configure all of these integration points, set all of the port mapping for all of the containers that were running in this whole suite, and the environment variables that allowed us to configure the various points in our web services and web applications, and the volume management to allow us to persist data as we tore down and then spun up all of our containers. From there, this also allowed us to manage all of our tags and all of our images that we were pulling in from our remote container registry. And we decided this wasn't even enough. We needed to make it more simple because we're trying to get a group of developers to do something new. And how do you do that? You make it simple and you make it well documented. So we simplified this process even further by adding and wrapping this entire Docker Compose and suite of web services in a command line interface, which we finally called the Sandbox CLI. So this allowed our engineers and even non-technical people to jump in and spin up this entire suite of services with a single command and initialize our databases, which needed to be pre-configured, and provide our developers with easy shortcuts as they run through the development process to speed up the process of tearing down, restarting, and updating all of the various containers that we are managing in this suite of web services. So once this process was in place, this allowed our engineers to easily set up the entire suite of services on their laptop with a single command, the shortcuts that they need to speed up their development process, and to be able to swap out images with instances that are running on their local machine as they develop. So using these commands available in the Sandbox CLI, we're able to quickly turn off a service that's actively running in the Docker Compose, and then insert an instance of that service that's running on the developer machine. From there, though, we recognized one additional problem, and that was the runaway complexity in our continuous integration and continuous deployment strategy, and which remained complex due to the number of languages and frameworks that we were still using in all of our web services and UIs. Now, as we notice here, each language and framework requires a different process for compiling, pulling in tools, and then actually building the Docker container that's going to be deployed and pushed out to our container registry. This also became a problem in our automated processes because as we pull in new services, we need to recreate this process based on the language that was used for each new additional service. So the nice thing about this, though, was that the Docker file was simple. Just 2 lines, pulling in a precompiled instance of the application, and then exposing an entry point for Docker to consume. To solve this problem, we looked at utilizing multi-stage builds for all of our Docker files. This allowed us to wrap all the complexity for each one of these individual languages and frameworks into the Docker file itself. So the engineer who is building this Docker file locally no longer has to have any knowledge of the actual tools and build process to actually build an image for each one of these. That now lives in the Docker file, which is deployed with the source code itself. So this did add to the build times, but it was worth it in the long run because this also dramatically simplified our CI/CD pipeline, where we had the same exact problem. So all of our automated pipelines for each application required a different process to install the tools, to compile its executable, and then to build and deploy its Docker image. This complicated the process in which we grew our application platform out because we didn't have a repeatable process to set up a continuous integration pipeline. And this really hindered the process in which we deployed new services. So the big gain that we got out of multi-stage builds was a unified continuous integration process that was then repeated across all of our existing services. And this allowed us to have a repeatable process that we can then apply to every single web service that we build out in the future, dramatically speeding up our growth of web services and our scalability as an entire platform. This ultimately solved our problem of managing our complexity in our web services platform and allowed us to more effectively manage our costs as our web services grow within our cloud services. And this ultimately got us one major step closer to solving our bigger picture problem, which was deploying this entire suite of web services out to a customer site without the need to reach out to a third party or internal cloud services. All right, so where do we go from there? We are now one giant step closer to solving our big picture problem of deploying our web services out to customer sites without requiring a connection to the cloud and to the outside world. And now that we have wrapped up all of our services into containerized solutions, we're looking at employing technologies like Kubernetes to elegantly manage our scalability of our web services as our client base grows and as the load on our cloud services grows as well. So This was a really amazing project that we have been cooking up for the past couple months now, and it's ultimately taking our tech to the next level.